Hey there, Mr. Richards here. Today's lesson is on inverse linear functions. Our key concept here is inverse relations, and in words, if one relation contains the element AB, then the inverse relation will contain the element BA. Here we have an example of what this looks like. If we have -3, -16, the inverse of that is, well, -16, -3. -1, 4 is 4, -1. 2, 14 is 14, 2. 5, 32 is 32, 5. They kind of just switched the ordered pairs. Our AB became BA. So when I go to find the inverse of each relation, notice we have 4 ordered pairs in our first one. So we can list each of these ordered pairs here. And we'll have -3, 26, 2, 11, 6, -1, and -1, 20. Now, as these become inverses, notice how -3, 26 is going to be 26, -3. 2, 11 is going to become 11, 2. Notice how we're just exchanging out -1 and 6, and 20, -1. So when I write my final answer here, we'll use our brace, and the inverse function is 26, -3, 11, 2, -1, 6, and lastly, 20, -1. And actually, I ran out of room for my brace on the other side, so we'll just kind of throw it there. What about the next one? Well, we have 4, 8, -6, 6, 3, 3, and 0, -8. 4, 8 is going to become 8, 4. -6, 6 is going to become 6, -6. 3, 3, tough one there, 3, 3. And 0, -8 is going to become -8, 0. So when I go to rewrite this one, start with your brace, and we have 8, 4, 6, -6, 3, 3, and lastly, -8, 0, and this time I did save room for that brace. So that's how you find the inverse of relations when you're given the ordered pairs. What about when we're given it in table form? Well, we'll just go right to our brace here. When we're given it in table form, let's put this back into actual ordered pairs. So -4, -3 is going to be -3, -4. -2, 0, well, the inverse is 0, -2. As for 1, 4.5, becomes 4.5, 1. And 5, 10.5 is going to become 10.5, 5. Closed, room for the brace. That's it. Next example. Now when I go to graph the inverse of the relation, let's look at some of the ordered pairs I already have. Well, as I look here, I have a point there, and that appears to be at -1, 1, 2, 3, 4. So we have -1, +4. We have our y-intercept seems to go through 0, 2. And if we look for at least one more point, I have 1, 0 there. And basically try to find as many as you can, 2, -2. So you can get an idea of what's going on. Having 4 is very helpful. Getting both intercepts, getting one in different quadrants. When I go to graph the inverse of this then, well, create the inverse points. We're going to have 4, -1, 2, 0, 0, 1, and negative 2, 2. And graph it. 4, negative 1 is here. 2, 0 is here. 0, 1 is there. And negative 2, 2 is here. And it does, luckily, form a line. It goes through those points. Arrows at the end of our lines. And there's our inverse graph. Let's look at one more. Again, let's find points on this graph. Well, as I look at my graph, there's a point here at negative 1, negative 3. And as I continue going along my graph, we have a point here at 1, 0. Continue, 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 continue. There's one at 3, 3. And that should be good enough to get our answer done. We have negative 3, negative 1 is the inverse point. 0, 1 is an inverse point. And, well, yeah, 3, 3 is the inverse point here. So negative 3, negative 1 is a point. 0, 1 is a point. And 3, 3 is a point. And we go to graph this line, something like that. Let's continue on. Our key concept here is finding inverse functions. And to find the inverse function, this might be new notation for you. F negative 1 of x, of the linear relation f of x, complete the following steps. Step 1, we're going to replace the f of x with y. We're going to switch our y and the x in the equation. We'll solve for y. And at the end, we'll replace y with this new notation, f to the negative 1 of x, in the new equation. Let's see how this works out. Find the inverse of the function f of x equals negative 3x plus 27. Well, our first step is to replace f of x with y in the equation for f of x. So we're going to have y equals negative 3x plus 27. Then interchange the x and the y in the equation. So x is going to equal negative 3y plus 27. Now we want to solve that equation for y. So let's get the y alone. Subtract 27 from both sides. You have x minus 27 equals negative 3y. Divide everything by negative 3. And we'll come up here with this. We'll have negative 1/3 x plus 9 equals y. Or we could just write that out. Y equals negative 1/3 x plus 9. Our last step is to take our y equals negative 1/3 x plus 9 and replace that y with our inverse f of negative 1 of x equals negative 1/3 x plus 9. And that is how we do it. So again, step by step. Replace f of x with y. Switch your x and y. Solve for y. Replace y with f to the negative 1 of x. Let's try it one more time. Let's replace the f of x with y in the equation. So we'll have y equals 5/4 x minus 8. Next, interchange y and x in the equation. So x equals 5/4 y minus 8. Solve this equation for y. So we have x equals 5/4 y minus 8. Start by adding 8 to both sides. And we'll have x plus 8 equals 5/4 y. And you could divide by 5/4 on both sides, but I think the easiest thing to do to get our y alone here is to multiply by the reciprocal of 5/4, which is 4/5, to both sides, to everything. And as we once again move up here, we'll have 4/5 x plus 32/5 equals y. Or simply, y equals 4/5 x plus 32/5. Well, then our last step is to replace that y. So f to the negative 1 of x equals 4/5 x plus, might as well just keep it, 32/5. And that's our equation. Carter sells paper supplies and makes a base salary of $2,200 each month. He also earns 5% commission on his total sales. His total earnings f of x for a month in which he compiled x dollars in total sales is f of x equals 2,200 plus 0.05x. Our first question is asking us to find the inverse function. Let's go through our steps again. Let's replace f of x with y. So this is going to become y equals 2,200 plus 0.05x. Now we're going to interchange. So x is going to equal 2,200 plus 0.05y. Now we get to solve this equation again for y. So we can start by subtracting that 2,200 from both sides. Cancels. We're left with x minus 2,200 equals 0.05y, or 5/100ths y. Now we get to divide by 0.05, everything by 0.05, that is. And we'll move up here for our solution. Now, it's pretty neat. If you were to type in 1 divided by 0.05 into a calculator, believe it or not, you would get 20. So this is going to be 20x, and 2,200 divided by 0.05. We're going to have minus 44,000, and that's going to equal our y. So then we get to replace that y, so we'll have f to the negative 1 of x is going to equal 20x minus the 44,000. So really no different than what we just did in finding inverse functions in earlier examples, but now it's just a real-world problem, and one that we can actually do a little bit more with now. So we found the inverse function already. So let's recopy that here. And that inverse function was f negative 1 of x equals 20x minus 44,000. What do x and f to the negative 1 of x represent in the context of the inverse function? Let's think about what x means. X, well, the x is Carter's total earnings for a month. But what does this f negative 1 of x represent? Well, this represents his total sales for the month. So now when we look to find the total sales for last month, we can say f of negative 1 of x equals 20x minus 44,000. We can put in the 3450 for x. So f to negative 1 of that 3450 is going to equal 20 times 3450 minus 44,000. 20 times 3,450 is 69,000 minus the 44,000. And so we can finish this and say this is $25,000 in sales. That's it. Good luck.